There's different symmetry tests that we look at because I mean one of the other things that sometimes comes into play, especially when you start dealing with like courses in calculus and beyond calculus, is whether or not you have an even or versus an odd function. Because even functions will behave certain ways, obey certain proofs, satisfy certain theorems that odd functions won't, and vice versa. Now, there's different ways to determine whether or not you have an even or an odd function. Um, and what their symmetry is with respect to, on the graph. Like for instance, even functions, um, they would have they'd be symmetric with respect to the y-axis. Formula wise, f of x would equal f of negative x for every number x in the domain of f. An odd function, if you're looking at it graphically, would have symmetry with respect to the origin. Or from another formula, for a more function standpoint, f of negative x would equal negative f of x. Whichever way you're defining it, it's going to depend on the situation that you have, um, in front of you. I mean, if it's graphical, you're obviously going to want to go with like, well, if this point's on here, then this point should be on here. Like for instance, just kind of pick a point here at random. It looks like here at -3, -20, I have a point right about here on the graph. Okay. So, if it was an even graph that at +3, -20, right about here, I should have a point. Well, I don't. It's really easy to see symmetry about the y-axis anyway, and I can clearly see I don't see a mirror image across the y-axis. Now, what I do see is, well, here I have -3, -20. Here I have +3, +20. So, if I have one set of coordinates and another set of coordinates that's the exact negative of both the x and y, and that happens for every point I have on the graph, and if you look carefully, you can see that does happen, then that would be the instance of having an odd graph. That's what I mean by being symmetric with respect to the origin. Or if you look at it, it's like I kind of flipped it across the y-axis and I flipped it across the x-axis as well, and I got this. That's how I get the superimpose. So because of that reason, this is an odd function. For b, I really don't see any symmetry. I mean, it looks like I have 1, 5 as a point on the graph, but -1, -5 is not a point on the graph. It's not odd. I don't see that symmetry across the y-axis where I have an exact mirror image on the other side, so it's not even. So it's neither. And not unlike integers, it can be odd, even, or neither. So it is neither here. Whereas C, I am seeing that symmetry across the y-axis. I'm seeing the left-hand side and a mirror image of it on the right-hand side of the y-axis. This is an even function. So graphically, you kind of get used to seeing what you need to see to determine one or the other. But what if you don't have a graph? Well, one way is to possibly graph it, but sometimes when you're graphing things, you may overlook a piece of information you might need to produce the graph effectively. And secondly, I mean, sometimes graphing some of these things could be rather tedious and take you quite some time. So that's when we start using the formula idea. And that is, well, if I can show that f of x equals f of negative x, then it's even. If I show that f of negative x equals the opposite of f of x, then it's odd. And if neither one of those two things happen, then it's neither. So we run these tests. The first one we always run is the easiest. I see that I have f of x. I do f of negative x, means I replace all the x's with negative x. And you see there's only one place I have it. If I square negative x, I do end up with positive x squared. So f of negative x ends up being the square root of 2x squared plus 5, which is what f of x was. So we just shown that f of negative x equaled f of x. That's an even function. When I look at e, I first do f of negative x. I replace all the x's with negative x's. If I square negative x, I end up with positive x squared. If I distribute the positive 2, I get a minus 2x. So I get x squared minus 2x. Well, x squared minus 2x and x squared plus 2x is not equal for every possible value of x. You might be able to find a value or two, like in this case 0 would be a value where they are equal to each other. but they're not equal to each other for every other value. I mean, I could pick like the number 1. Well, one's 1 plus 2, the other one's 1 minus 2. 1 plus 2 is 3, 1 minus 2 is negative 1. Those aren't the same thing. But you do have to make sure you're showing it with respect to x. You don't want to just pick a single point, and that's a mistake I've seen students do in the past. They'll say, well, if I do f of 2, I get 4. I do f of negative 2, I get 4. It's even. Well, it worked for 2 and negative 2. Did it work for every other possible x combination? Well, if you haven't tried all of them, you're not going to know. So, but you typically x squared minus 2x is not going to equal x squared plus 2x under most circumstances. Therefore, we can't. Therefore, I know it's not going to be even. Now I compare f of negative x to negative f of x. So I do the opposite of x squared plus 2x. I get negative x squared minus 2x. Not the same thing as x squared minus 2x. You know, having that negative in front of the x squared and not or not, that's going to change, you know, whether they're the same thing or not. So they're not the same thing. So in this case, it's neither. Whereas I go to the third one, fourth one here. Yeah, third. There was 6 in totals. This is actually number 6, but third on this page. X cubed plus 2x for being a function of x. Well, again, I'm going to try to put negative x in there. And if I do that, I get negative x cubed minus 2x. That is not the same thing as x cubed plus 2x. If anything, it's the exact opposite. And that's what we're getting at here. If I do the opposite of f of x, which means I'm going to take the quantity x cubed plus 2x and negate it, when I distribute that negative symbol, I get the exact same thing, negative x cubed minus 2x. Therefore, this is an odd function.